Hello friends, welcome to engineering tutorial. So far we have discussed around 3 questions on superposition theorem, the application of superposition theorem. So this is the 4th question which we are going to discuss. So this is the circuit here, and it consists of 3 independent sources. One current source of 10 milliampere and 2 DC voltage sources, 25 volt and 15 volt. Okay, all of them are DC and independent. So the question is, we have to find the voltage drop across this 1 kilo ohm resistor. So we will do it by superposition theorem. This circuit can be approached in a lot of ways. We can apply KVL, we can apply nodal analysis, mesh analysis, or we can apply network theorems. There are other network theorems also which we can apply, let's say Thevenin theorem, Norton theorem, or we can apply superposition theorem. So we are discussing from the point of view of superposition theorem. So let us apply that. So we will go by the superposition theorem principle, which means that we have to consider one source at a time. So as there are 3 sources, we have to do it in 3 steps. There will be 3 steps involved. Okay, first we will consider the 10 milliampere current source, and we will short circuit the 25 volt and 15 volt voltage sources. So let us redraw the circuit. This is step 1, considering the current source, 10 milliampere current source. Milliampere. Four kilo. This is This is 1 kilo. This is a short. Voltage sources are short circuited. This is also short circuited, 15 volt, and this is 3 kilo. Now, because of this short circuit connection, the 25 volted with which is short circuited, this 3 kilo ohm goes out of this circuit. It has no role to play. We can replace it with this. Just remove this. Because of this short circuit, the 3 kilo ohm resistance, it has no role to play in this circuit, because the equivalent resistance will be will be that because of this. The current will never flow through this 3 kilo ohm resistance, because it will always take the short circuit path, the path of minimum resistance. Okay. Now, we have to find this current here. Okay, let us call it I1, so that we can find the voltage drop by multiplying this current with 1 kilo ohm. So this is a perfect thing to apply the current division rule. The 2 resistor form, it is there. So in order to find this I1, we have to apply current division rule, which is I1, which is equal to 10 milliampere to the other resistance, which is 4 kilo ohm, the sum of the resistances. So 4 kilo ohm is 1 kilo ohm, which is 10 into 4 by 5, which is 8 milliampere. I1 is 8 milliampere. So the voltage drop across 1 kilo ohm, the sign convention is very important. Now, I have already discussed in the basic concepts related to resistive circuits that current always flows from positive to negative terminal of a resistor, inductor, capacitor, because these are all power absorbing elements. So, the polarity will be like this. Let us call it dash. So, this V1 kilo ohm is equal to 8 milliampere into 1 kilo ohm, which is equal to 8 volt, and please notice the polarity, it is plus minus. This polarity is very important. Okay, so this is what we got from the first step. The voltage drop across this 1 kilo ohm resistor because of this 10 milliampere current source is this much. And if you have any doubt, because we short circuited this 25 volt voltage source, this 3 kilo ohm resistor, it goes out of this circuit. It has no role to play because the equivalent resistance will always be 0. Short circuit means the resistance is 0. So, the equivalent resistance will be 0. So, we removed this whole thing and we replaced it by a short circuit. Okay. Because of this short circuit here, the 25 volt and 15 volt, these two voltage sources are short circuited as per superposition theorem. So, because of this short circuit connection, the 3 kilo ohm goes out of the circuit. It has no role to play. So, we redraw the circuit in this way, and we applied current division rule to determine this current flowing through 1 kilo ohm so that we can find the voltage drop across it. So, this is because of 10 milliampere this current source. Now, we have to consider 25 volt short circuiting 15 volt, open circuiting 10 milliampere. Then we will consider 15 volt short circuiting 25 volt, open circuiting 10 milliampere. So, 2 more steps. Okay, so let us do that. So, this is step 2, in which we will consider the 25 volt voltage source. So, we have to open circuit 10 milliampere, short circuit 15 volt. Okay. So, let us do that. This is short circuited, the 15 volt, this is 3 kilo. Okay. Now, if you look at this circuit, you will find that this 3 kilo ohm resistor, it is connected across the 25 volt voltage source, and this 4 kilo ohm and 1 kilo ohm together, they are also connected across this 25 volt voltage source across the two ends. So, this 1 kilo ohm and 4 kilo ohm, they are connected in series across this 25 volt voltage source. Okay. Here we can apply voltage division rule. So, just let us draw the circuit in a different way so that you can understand this. So, it is just like this. See, just focus on this portion. This. We have to find the voltage drop across this 1 kilo ohm. So, we can apply voltage division rule. So, the voltage division rule, if we apply, let us call the voltage drop across V1 kilo ohm as V1 kilo ohm double dash for step 2. So it will be simply 25 volt into the same resistance by the sum of the resistance 1 plus 4, which is basically 5. So it will be 5, it will get 5 volt. So now the polarity, what about the polarity? Okay, this positive terminal, it is connected to this end, the negative is connected to this end, so it will maintain the same polarity throughout. This will be positive, this will be negative. So the voltage drop across 4 kilo ohm will also follow the same order, positive, negative, because current will flow in this direction from positive to negative. Whatever current will flow, it will start from positive, end at negative terminal, and current always flows from positive to negative terminal through the resistor because it is a power absorbing element. So I have already posted videos related to the basic concepts related to electrical circuit analysis, voltage division rule, current division rule, about the capacitors, inductors, resistors, about series and parallel connection of resistors, inductors, capacitors. In the circuit theory playlist or network theory playlist, you can check those videos. So here the polarity of the voltage is minus plus. Previously it was 8 volt plus minus like this. Weak 1 kilo ohm in the first case, first step was like this, 8 volt, this order. Here it is opposite. Okay, so we have two steps we have completed. We have considered 10 milliampere and we have considered 25 volt. Now we have to consider 15 volt short circuit, 25 volt open circuit, 10 milliampere in step 3. Okay, so let us do that. So now we will do step 3, in which we have to consider the 15 volt voltage source and deactivate 25 volt and 10 milliampere, which means we have to open circuit 10 milliampere, short circuit 25 volt. So let us redraw the circuit. It will be open circuiting 10 milliampere. This is 1 kilo ohm. Sorry, it is 4 kilo ohm. Sorry, it is 4 kilo ohm. This is 1 kilo ohm. And this is short circuited, 25 volt short circuited, and this is 15 volt. Okay, now this is a very interesting case. Because this 25 volt is short circuited, okay, please pay attention, because this 25 volt is short circuited, this 1 kilo ohm and this 4 kilo ohm, they play no part in this circuit, they go out of this circuit, because current will never flow these two circuit elements, because it will always take the least resistance path, which is 0 here. It will start from here and flow in this closed loop. It will never flow through this 0 ampere. It will be 0 ampere. It means that these two resistors, 1 kilo ohm and 4 kilo ohm, they will play no part in this circuit. So this circuit is same as this. Just this, because of this short circuit connection. Okay, this short circuit connection, it will be this, and the current will be voltage by resistance, which is 5 milliampere. 15 by 3, 5 milliampere, and no current will flow through this. So if 0 current flows through 1 kilo ohm resistor, it means the voltage drop across 1 kilo ohm in the third case, triple dash, is 0 volt. Okay, you understand? Because of this 25 volt getting short circuited as per superposition principle, these two resistors 4 kilo ohm and 1 kilo ohm, they play no part in this circuit, because current will always take the minimum resistance path. Okay, it will flow through this short circuit path, it will never flow through this path having resistance. So it will be 0 ampere or 0 milliampere current flowing through this 1 kilo ohm and 4 kilo ohm resistors. So because 0 current is flowing through this 1 kilo ohm resistance, voltage drop will be 0 volt. Okay, so here we have got the 3 voltage drops. Okay, this we have got this 3 voltage drops. Now the voltage drop across 1 kilo ohm will be simply the addition of the individual voltage drops, that is V 1 kilo ohm dash plus V 1 kilo ohm double dash plus V 1 kilo ohm triple dash. So this is plus minus, means the polarity is from plus to minus this, so it will be 8 volt. This polarity double dash is minus to plus 5 volt, so it will be minus 5 volt. This is 0, so no question of polarity, it will be 0 volt. So the net polarity is 8 minus 5 volt, which is 3 volt. So here the polarity, the polarity which I placed on the top, plus minus minus plus, that is very important. Okay, that's why I said always pay attention to the polarity of the voltage drop across the resistor, or the polarity of the voltage source, the direction of the current. I think I have posted a video related to that. In the I discussed about it in the source transformation and also in the basic concepts related to resistive circuits. It is in the circuit theory playlist, so you please check out those videos. Okay, there I have discussed in detail about this of all the introductory concepts related to circuit analysis. Okay, about source transformation, about the voltage drops, about the power, which is power absorbed, which is power power delivered, what is the sign convention of the voltage drops across capacitors, resistors, inductors. So I have discussed about them in detail, so you please check out that video. So this will be, the polarity will be like this. This is 3 volt with polarity like this. It means the voltage drop across the 1 kilo ohm resistor is this. What is this? Plus minus 3 volt. This is the polarity of the voltage from plus to minus, and this is the magnitude, 3 volt. Okay, so this was a very good question because it involved 3 sources, 1 current, 2 voltages. We also got to know about various concepts while solving this circuit. We used voltage division rule, we used current division rule, and all the other things. So this is a very good question. Okay, so we have solved this circuit and we achieved the objective of finding the voltage drop across 1 kilo ohm resistance, and we did it using superposition theorem. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.